All right, so let's look at 5.1 here on graphing linear inequalities. The unit title for Unit 5 is Linear Inequalities. Again, like I said in the announcement video, there's just going to be 3 sections of this. All right, so our objective today is that you'll be able to graph linear inequalities. And I've got 5 examples that we're going to do to show that. This falls under the standard of AREI 12, being able to graph the solutions to a linear inequality in 2 variables. And so let's review a couple things that some of you are having some struggles with. These 2 forms here. Remember that slope-intercept form is y equals mx plus b. And the standard form of an equation is ax plus by equal to c. And so remember in slope-intercept form that the m is the slope, right? And the y-intercept is the b. So if I have like y equals 2x minus 5, the slope would be 2 and the y-intercept would be negative 5. Now, if we're dealing with something in standard form, like let's say 3x minus 4y is equal to 12, remember that that is not going to just show me the slope because I have it next to the x. This 3 is not the slope. And so remember that we can do one of 2 things. We can solve for our intercepts. The x-intercept, remember, will be x comma 0, so I plug in 0 for the y and solve for x. And the y-intercept would be 0 comma y, putting 0 for x, solving for the y. Or I could solve the entire equation for y and get it into slope-intercept form. So just a little quick review on that. All right, so let's now review our inequality symbols. And so remember that this symbol, opening to the left, is greater than, because remember we read left to right. So A would be greater than B, right? If we put the bar underneath, of course that's greater than or equal to, less than when it opens to the right, and less than or equal to because the bar, again, is underneath. Now, just doing a little bit of review again, if I was graphing a 1 variable inequality on the number line, like, oops, let's not scroll all the way down there, but if I have x is greater than 3, right? And I go on the number line, I would go to 3, 4's to the right, 2's to the left. What would I do at 3? We put a circle, right? Because is 3 a solution to this inequality? No. But what would be a solution? Well, 4 would be a solution and 5 would be a solution because those are numbers that are greater than 3. So my shading would go this way. And so when we graph in 1 variable on the number line, we deal with circles and dots, and we deal with shading going one direction or the other. Now, when we deal with a 2 variable problem, we will still have shading, but our line will be one of 2 methods. If I am equal to, so if I have the symbols greater than or equal to, or less than or equal to, the line that I draw for the inequality will be solid because the points along that line will be included in the solution set. If it is just greater than or just less than, the line will be dashed because the points along the line will not, again, the points along the line will not be a solution to the inequality. And we'll talk more about solutions in tomorrow's lesson. Today we're focusing just on the graphing. So here we have y is greater than or equal to 3x plus 1. And so let's talk steps. Step 1, and I wish this would stop jumping on me. Step 1, graph like it is an equation. So if it's in slope-intercept form, we're going to find the slope and the y-intercept and use that to graph this. If it's in standard form, we'll find the x-intercept and the y-intercept and use that to graph it, and we'll look at that in a couple of examples in a moment. So if I have y is greater than or equal to 3x plus 1, my slope, the m, is 3, and my y-intercept is 1. And so remember that we start with plotting the y-intercept, and then my slope is going to take me up 3, right 1, and I could continue that pattern up 3, right 1, up 3, right 1, and I can reverse the pattern down 3, left 1, down 3, left 1. And with inequality problems, you want to get as much coverage of this graph as you can. You don't just want to put 2 points and be done and just draw a little short line. You want the line to be as long as the graph allows you to draw it. Because here's the issue. once we draw this line, we're going to have shading on one side of the line or the other, because the shading represents where the solutions will happen. Now, I'm going to give you a couple little ways to understand where the shading will be in these problems. But let's talk about step 2 first. Step 2 is to draw either a solid or dashed line. Now, how do we know which one we're going to use? We look back at our inequality. If it is equal to, my line will be solid. If it is not equal to, my line will be dashed. In this case, I am equal to. It doesn't matter that it's greater than or less than. The key is that it has the equal to bar underneath. And so this line will be solid. And so we're going to connect all these points down this line and make it a solid line. Now, here comes the next step. Where does the shading go? So what I'm going to do is I'm going to pick a point that is on one side of the line or the other. It doesn't matter which side I start with. But what do you think the easiest ordered pair is going to be to choose to plug into this? And so step 3 is to check a point to see which side of the line to shade. And it goes back to like what we did in the example up here. What value is going to be greater than 3? Well, 4 is greater than 3, right? But we're dealing with a 2-variable problem, so I can't just pick like x being 2. I have to pick x being 2 and y being 5, right? So if I go 2, 5, and so that point would be here. But what's the easiest ordered pair to choose? Well, it'll be the origin, because the x is 0 and the y is 0. As long as my line does not go through the origin, I can choose 0, 0 every time. And so watch what happens when I plug in 0, 0. I'm going to get 0. Is that greater than or equal to 3 times 0 plus 1? Well, 3 times 0 is 0, so 0 is greater than, is it, because it's a question mark, 0 plus 1. So the question is 0 greater than or equal to 1? The answer to that question is no. 0 would actually be less than 1. So where the origin is, which would be right here, just to the right, or just beneath my line, that point does not work. And so that point, again, is either to the right or below the line, depending on how you're thinking about it. And so where's my shading going to go? It's not going to go where I put the x. It's going to go on the opposite side. It's going to go all up here. So all of this region here would be shaded. Now, what does that mean to the graph? Just like we do on the number line up here, right? So anything in this shaded region would be a solution, right? So 3.5 would be a solution, 8 would be a solution, 1,000,000 would be a solution, right? Any ordered pair in this orange shaded region, or any ordered pair along this red line, will be a solution to this inequality. Now we're going to talk more about individual solutions tomorrow with section 5.2, but today we're just worrying about graphing them on the coordinate plane. All right, so think about that there. Let's look at example number 2 here. So again, this is in slope-intercept form, y less than -1/2 x minus 3. So let's identify our slope and identify our y-intercept. What is the slope of this inequality? Remember, that is the number attached to the x in slope-intercept form. So that would be the -1/2. What is my y-intercept? Well, my y-intercept is the -3. So as we plot this out, I'm going to go to -3, 1, 2, 3 right here, -3. And then my slope is going to tell me to go down 1, right 2. And I'm going to continue that pattern again until I get to the edge of the graph. Again, I know some of you like to just put 2 or 3 dots and be done, but for inequalities, like I said, it is very important that you take this as far out to the edges as you can. Now, that was step 1, right? Step 1, graph like it's an equation. We did that. Step 2, draw either a solid or dashed line. Well, which one am I going to draw here? Look at the inequality. It says that y is less than. And so what am I going to draw? A solid line or a dashed line? It's dashed because it's not equal to. There's no equal to bar underneath. So I'm going to dash this line as we go through the coordinate plane. Now, here comes step 3, the shading. Where's the shading going to go? my line does not go through the origin, so I'm going to test the origin. So I'm going to do 0 less than negative 1/2 times the 0 minus the 3. So 0 less than 0 minus 3. So is 0 less than negative 3? Is 0 less than a negative number? No, it is not. So this test point again fails, so my shading will not be where that x is. My shading will not be there, but it'll be on the opposite side of the line. So in this case, I'm above the line, right? So my shading will not be above, but it will be below. So everything down here, everything below this line is the shaded region. Now, again, we're going to talk more about solutions tomorrow, but the reason why this line is dashed is because if I take one of the points that is on that line, it will not meet this same standard. Okay, and again, we'll talk more about that tomorrow in 5.2. All right, let's look at example 3 and example 4, where both of those are in standard form. And so I'm going to do example 3 by finding the intercepts, and I'm going to do example 4 by solving for slope-intercept form. So in example 3, I'm going to look for the x-intercept and the y-intercept. And again, this is how we graph something that is in standard form. And so I'm going to give myself a little space here. So I'm going to do, so remember this is going to be in the form x comma 0. So I'm going to plug in 0 for the y. So I'm going to get 2x minus 3 times 0 greater than 6. Now, for the sake of finding the intercept, we'll change that to an equal sign just for these steps. When we actually graph it, we'll still deal with the inequality that's over here. But for now, we're just going to deal with the equal sign. So this goes to 0, so 2x is equal to 6. We're going to divide both sides by the 2. And so that x is equal to 3. So my x-intercept, and I'm sorry that my screen keeps jumping on us, but my x-intercept is 3, 0. So I'm going to put that point on my coordinate plane right there. Now, for the y, we're going to do the same thing, except remember that the y-intercept will be in the form 0, comma y. And so I'm going to plug in 0 for the x and solve for y. So 2 times 0 minus 3y equals 6. That becomes 0. So I get negative 3y is equal to 6. And dividing both sides by the negative 3, I get that y is equal to negative 2, meaning that my y-intercept is 0, negative 2. And again, this is a step some of you have issues with when it comes to solving for these intercepts. These are two separate points on the coordinate plane. The x-intercept at 3, 0, that's the purple dot, and the y-intercept 0, negative 2 at this red dot here. Now, we're going to connect these two dots and make a line. Now, I could also extend this line with more dots. And so if we look at the slope, I'm going up 2 and right 3. So up 2, right 3, up 2, right 3. And I can go down to left 3. And I could, again, continue the pattern all the way out to the edges as far as we can go. What type of line will I draw here? This is step 2. This does not change from what we did in examples 1 and 2. If the inequality is equal to, then we're going to have a solid line. If there's no equal to bar, then I'm going to be dashed. And in this case, it's not equal to, so my line is dashed. And so there's my line. Again, we'll test an ordered pair. And our best ordered pair is which one? That's right, 0, 0. And so I'm going to plug in 2 times the 0 minus 3 times the 0. Is that greater than 6? That's 0. That 0 is 0 greater than 6. No, 0 is not greater than 6. Now, these first three examples, all of them have failed at 0, 0. That's not always going to be the case. If 0, 0 works, you're going to shade where 0, 0 is, wherever that happens to be. If it's above the line or below the line, wherever it happens to be. So again, I'm not going to shade up here where 0, 0 is in this case because it did not work. But I will shade the opposite side down here. Now, I could test a point that's down there, right? So I could test a point, like let's say this is 5, negative 5, right? We could test that real quick and just see that it will work. So 2, and I'm, again, apologizing for the screen jumping. 2 times the 5 minus 3 times the negative 5. Is that greater than the 6? This is 10 plus 15. 25 is definitely greater than 6. So again, the order pair 5, negative 5, which would be right here, is definitely a solution because it meets the requirements. It gives us a valid solution in the end. Okay, so again, that is finding it using the intercepts. Let's go to example 4. 5x minus y is less than or equal to 10. Now in this problem, I'm going to solve this into slope-intercept form. So I want this problem to get the y by itself. And so to do that, we're going to move the x first. So I'm going, in this case, subtract 5x from both sides. And please, for the love of all that is good, do not combine these two together. This is negative y less than or equal to negative 5x plus 10, or 10 minus 5x. Okay? Now, our next step. We got to divide both sides by this negative 1, because remember, if there's no number in front of the y, there's a 1 in front of it. So that means I have negative 1 here. I'm going to divide both sides by negative 1. Now, go back to what we did with one variable inequalities. If I divide both sides by a negative, what must happen to the inequality? We've got to flip this inequality on our next step. And so I'm going to get that y is going to be greater than or equal to negative divided by negative is positive, so this will be 5x. Positive divided by negative gives me a negative 10. And so now I'm going to ask, what is my slope and what is my y-intercept? My slope is 5. My y-intercept is negative 10. So I'm going to count all the way down to negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm way down here. And my slope is 5. And remember that 5 is over a 1 because 5 divided by 1 would give me the 5. So I'm going to go up 5. 1, 2, 3, 4, 5, and right 1. Up 5, right 1. Up 5, right 1, and up 5, right 1. Is this line going to be solid or dashed? This one will be what? Solid, because it is equal to. And so I'm going to connect these dots with a nice solid line coming all the way through. And it would be recommended that if you're doing this on paper and pencil to use some type of straight edge, use an index card or a ruler that you have to make this line as straight as possible. Now, last step, where's my shading going to be? What order pair should I plug into the original problem to see if it's going to work or not? What's my best point to choose? Remember, my best point to choose, if I can choose it, is the origin. So let's try it. 5 times the 0 minus 0. Is that less than or equal to 10? Well, that's 0 minus 0. Is 0 less than or equal to 10? You betcha, because 0 is less than all positive numbers. So this point checks out this time. So if it checks out, I shade where that point is. It doesn't matter if it's above or below or right or left, I shade where it is. And in this case, that is above this line or to the left of this line. And so any point in that red shaded region and any point along this green line would be a solution of this inequality. All right, last problem I want to talk about, and this is one that I saw some issues with as we were working through horizontal and vertical lines. And so I want to come back to a problem like this. Y is less than 3. Now, this looks like a one variable problem because it is one variable, but we're dealing with this being graphed on the coordinate plane. And so think about what that statement says for a second. It says that any y value has to be what? Less than 3. Well, let's think about this for a second. And again, we can graph this using our intercepts. I only have one intercept. My y-intercept will be at 0, 3. Because remember, the y-intercept, the x is 0, the y is the intercept. So I have a dot here. Now, common mistake. Some of you want to go right up and down this axis. That's not the way it goes. It goes perpendicular to it. It goes across this because this line, I'm looking for where is y equal to 3. So it's any point along here because there is no slope, right? There's a 0x here essentially. Is this line going to be solid or dashed? Look at the inequality. Not equal to. So it is what? Dashed. and I come across and dash this line as I go across. Where's the shading going to be? This says that y has to be less than 3. So try an ordered pair, right? If I plug in to y less than 3 and I plug in the ordered pair 0, 0, there's no x for me to plug in, but I do have a 0 for the y. So is 0 less than 3? It checks out. So my point at the origin right here checks out in this case. So where's my shading going to be? It's going to be where the dot is. And in this case, that is below this line. So my shading would be all down here. So that is linear inequalities, graphing them. Look through these examples. There are 12 problems in the assignment for today. Pay attention to what type of inequality you're given. Pay attention to what steps you need to take to solve this. The word of the day is inequality. Again, the word of the day is inequality, I-N-E-Q-U-A-L-I-T-Y, inequality. And I hope y'all have a great day. Again, if you have any questions, make sure you hit up the email or hit up that Google Meet and let me know that you need me to accept your invite. All right, so y'all have a great day, and I hope y'all are staying safe.